something. Okay, so what we are studying today?
So we'll do revision of any chapter.
Okay, so do you want to start motion and measurement of distance kind of thing?
Which chapter?
Motion.
Motion is not coming.
Okay, which chapter is coming?
Sir, I've sent you.
Just a minute. Let me check. Hmm. So structure of the atoms, fundamental unit of life, tissue, motion, forces and laws of motion. That right?
Yeah.
Just a minute. You have sent me. Okay. Chemistry, structure of the atom, biology, tissue, physics, force and laws of motion, gravitation, work, energy, power, and sound. Okay. Correct.
Yes, sir.
Yeah. So let us start force and laws of motion. So force and laws of motion is very interesting. Can you start?
Force and laws of motion.
Yes. Or do you want to have some other thing like sound or gravitation?
Can we do work, power, and energy?
Okay. Work or energy. Okay. Great. So I'm just opening my PDF. I have shared some worksheet along with you, right?
Yes, sir.
So have you done all those?
Um, my mom said we'll do like on 9th or something like that. That time we'll practice all the questions.
Hmm. Okay. Okay. So no, I think complete those things because it is very essential, right? Because as fast you can do, then I'll be able to understand. So your capabilities and also the where you are lagging, right? Hmm. Okay. Okay, so as we have discussed earlier, so work, you know what is work, and we have also shared the summary, right? Have I shared the summary of this chapter?
Hmm.
I am asking you summary.
Yeah, you sent.
So have you gone through those?
Yeah.
Okay. Any doubt?
Um, like for the potential energy, can you show me how is it derived?
Yes. Okay, so that potential energy is getting converted into kinetic energy, right?
Hmm.
And okay, so let me open that. So first, give me a second. Okay. Okay, so conceptual problems, the total energy of the body is constant at all points, right? That you are saying?
Then what?
Total energy is constant at all points of time. That you are saying? So the object is raised upwards at a certain height. There should be one potential energy, right? So after that, if the object is coming down, then the potential energy will be converted into kinetic energy. So the total energy, until the object is falling on the ground, will be remaining constant. That you are saying?
So I'm asking the derivation of
Yeah, so that's why derivation, right?
po- potential energy is equals to m into g into h.
Yes. Okay, let me share my screen first. So I think we have some trouble connecting to the internet. It becoming little slow. Just a minute. Is my screen visible? Is my screen visible?
Yes, sir. Sir, can you hear me?
Yes, I can hear you.
Okay.
Okay. So the work done, the definition of work done, can you remember? Can you tell me the definition? What exactly the work done is?
Work done is when a force is applied to the body which
Hmm.
causes the motion on that body.
Hmm. Okay.
Then the work is done.
Okay.
For example, when we move, uh, if there's a table and we are moving the table, if the uh, table moves, then the work done. Then we can say the work is done. But the table doesn't move, and how much pressure you give, then we'll say that the work is not done.
Okay. Now see, an object is placed on a surface, right?
Yeah.
And the work has been done. I mean, the some force has been applied. A force is applied, and it is allowed to bring at a certain distance. So let's say it is d, right? So at a distance d from the surface of the earth or ground. Okay. So work done has been done, right? Work has done, correct? Okay. So what is the work here? W is equal to, what is the formula for work?
W equals to F into D.
Okay, F into D. Now, D is the distance and F is the applied force on that object. Correct?
Yes, ma'am.
Now object has mass of m, right? So what is the force? You have studied in the motion and the forces of laws of motion. F is equal to
Yeah.
force is equal to mg, mass into gravity, right?
Yeah.
Mg into d. So it comes, actually it becomes now mgd or mgh. This is your work done, correct?
Yeah.
So this work done, so work has done in moving a distance d at a certain height from the initial place, I mean the surface of the earth. So we are moving an object at a certain height d or h. Okay, so this is work done. Now the most important part is that as this work done is equal to the energy equal to mgh, right? Because the work done and energy are interrelated, correct?
Yeah.
Because energy equal to this mgd, because it is gained by the object. Okay, and at a certain distance there is no motion of the body or object. That is why it has only potential energy. Hence we can say this work done is equal to the potential energy, E is equal to mgd. Clear? Clear?
Yes, sir.
So E is equal to m, g and d. So here you can write EP. P means potential energy. Correct? Any doubt so far? Any
Sir,
doubt so far?
no. Sir, can you revise the whole chapter? Like,
Yeah, so as you wanted this revision, this potential energy, that's why I'm saying, right?
huh.
Huh. Okay, now I'm going through the summary parts of the chapter and I'll be explaining you one by one. So let us see. And also, remember that I have shared you that worksheet and the summary. Just go through it and solve it. Okay. So the first thing is that work done is defined as the magnitude of the force that we have discussed multiplied by the displacement or the distance moved by the object. Okay. And this work done happens in the direction of the applied force, right? Simple definition. Work done is equal to force into displacement. First point. Clear?
Okay.
So W is equal to F into D. What would be the unit of work done?
Rule.
Joule, right? So 1 joule is equal to, so the unit of force into unit of displacement, right? So the unit of force is equal to Newton, right? So 1 Newton meter. Always remember this kind of small MCQ might come. So how do you derive the unit of, so how do you derive 1 joule is equal to Newton meter? Can you tell me? How can you say, so the work done, the unit of work done is equal to Newton meter? W is equal to FD. Okay. Now we are trying to validate we are trying to figure out the unit of each element. So for example, work done of so the unit of work done we have written 1 joule and it equals to unit of force 1 Newton into unit of distance or displacement, 1 meter, right?
Huh.
And it is in SI unit. 1 joule is equal to 1 Newton meter. Clear? Clear?
Yes, sir.
Good. Second thing, that work done has some, conditions. Work done on an object by a force would be zero if the displacement of the object is zero. That we have given enough examples earlier for that. So can you tell me where, so in which case the work done must be zero?
When when there is no work.
So when? Can you give an example?
Like there's a rock. How much pressure we put to that big rock, it won't
Hmm.
move. Means the work done is zero.
Okay. So, but the rock is not moving, right?
Yeah,
Great. So, for example, also the wall, if you push it, then the wall of a house is not moving, correct?
yeah.
So the work done in this case, displacement is zero. So, work done is equal to force into zero. So, it equals to zero, zero work done, right? And there is another formula just for your reference. So, let's say I'm applying a force on an object. So the direction of force is along x-axis. This is x-axis. Okay. And the displacement is happening making a certain angle with the x-axis or with the applied force. That is called theta. This is called displacement happening.
Okay.
Okay. So it is given in your textbook, right?
Huh.
So what is the formula? So the
This.
displacement is happening by making an angle theta with the applied force. So in that case, work done is equal to, you have to remember F into D. So theta would be there, but in the form of trigonometric function that is called cos theta. Okay, you have to remember this equation. W is equal to FD cos theta. Clear?
Yes, sir.
Yes. Now you need to remember two, the values of theta. One, theta is equal to 0 degree. Okay. And theta is equal to 90 degree. Clear?
Sir, can you?
So, so you need to remember two values of theta. One, theta is equal to 0 degree and theta is equal to 90 degree. So theta is equal to 0 degree means there is no angle between the displacement and the applied force. Simply,
Okay.
so you can say the displacement is happening along the force, along the direction of force, right?
Huh.
So theta, in that case, theta is equal to 0 degree. And let's say put the value of theta here. So FD, FD cos 0. Cos theta means cos 0. Theta is equal to 0. And you have to remember cos 0 is equal to 1. You need to remember cos 0 degree is equal to 1. Clear?
Okay.
And the second condition is that when the theta is equal to 90 degree, what does it mean?
Um,
What does it mean? Theta is equal to 90 degree?
it's the right angle.
Yes, right angle. So the displacement is happening at right angle to the direction of force. Correct.
Huh.
Then FD cos 90 degree. FD cos 90 degree. Cos 90 always zero. You have to remember. So the whole term becomes zero. So in that case, work done is equal to zero. Cos 90 degree is equal to zero. Sine means cos 0 degree is equal to 1. So you do not remember to the value of sine theta or sine because right now we are not going into deep concept. So only we need to remember cos 0 and cos 90. Clear?
Yeah.
Okay. Next concept. So that now energy. Okay. So an object having capability to do work is said to possess energy. Energy has the same unit of that work. That energy is the capacity of doing work. You always need to remember this. Energy is the capacity of doing work, right? And potent there are two types of energies so that the an object uh, possesses. For example, object is moving with a certain velocity, okay, and it is undergoing with the kinetic energy. It must have the kinetic energy. And we have learned that if m is the mass of the object and it is moving with a velocity b, then kinetic energy is equal to half of mv square.
Okay.
This you need to remember. And how do you prove it? Again, equation of motion. Got it?
Hmm.
Can you prove it?
Proving.
Prove that the kinetic energy is half of mv square. Just check the textbook. It is very easy. Just you need to apply equation of motion. Okay. Similarly, see, I have proved one energy, right? Potential energy is equal to mgd, right? So the expression of potential energy is mgd, correct?
Yeah.
Similarly, the expression of kinetic energy is half of mv square. So we have discussed many times earlier. So just check how we can prove it. Just check your textbook.
Yes, sir.
Okay, so have we done it? So we need to apply first the second equation of motion, v square is equal to e square plus twice as. Then we need to substitute the value of displacement s. Okay, right? And you need to apply force is equal to ma, where m is equal to mass and a is the acceleration. Okay, so again, then work done is equal to force into displacement ma into d or s. So you need to now substitute the value of s from the equation of motion. So it will be becoming half of m b square minus e square. But initial velocity is zero as the object is starting from rest. Then half of mv square. Okay.
Okay.
So work done is equal to the kinetic energy of an object. Kinetic energy possessed by an object of mass with a uniform velocity is ek is equal to half of mv square. Do you want me to derive this equation again?
Sir, I'm writing.
Very good.
Sir, can you take class tomorrow also?
Tomorrow at what time?
Like tomorrow also I don't have school, so you can take any.
Tomorrow morning I'm not available. So tomorrow, okay. Tomorrow 3 o'clock.
Okay.
ठीक है. Let me check once because I need to check what are the schedules for tomorrow I have. Uh,
Well, can you check it now because so that I can tell my maths teacher also?
do one thing. Are you available? Okay, tomorrow. mm, let's make it uh, 3 p.m. Okay, 3 to 4.
Sir,
Is
and
it is it needed for tomorrow? Is it needed actually, or else you can do on Monday?
Monday I have exam,
Which exam?
science exam.
Wow, Monday you have exam.
Ah,
Oh, excellent. Acha, you are saying na 9th Feb you have exam and you are asking if I can take on 7th and 8th, right?
10th my exam will start.
Huh?
10th Feb is my exam.
Ha.
So I am asking for 8th Feb tomorrow. Can you take one class for one
Okay.
hour and for 9th 2 hours?
Okay. So 9th tomorrow then tomorrow give me some time. By today evening I'll let you know at what time tomorrow I should take because tomorrow you are available whole day, right?
Yeah.
But the problem is that the during the first half in the morning time I won't be available. I'll be going out and I'll be back after 1 p.m. So I can have my lunch and I can connect with you at 2:30 or 3 p.m. Okay.
Okay.
ठीक है.
Okay.
Let's do one thing then. 5:30, 6:30. Okay, we'll be doing. And Sunday I need to check when I can actually, schedule your time because Sunday is very tough for me.
Well, Sunday is the most necessary time. Like,
Hmm. Okay, let me check. I'll try to figure out something for you. Okay.
and uh, when it's Sunday, can you prepare uh, questions for like the whole, from all the chapters?
Okay. Sure. So whatever these chapters you have sent me, so I'll create sample question papers and basically just you need to have a glance through them. But the main thing is that are you doing practice, right?
Yeah.
Without practice, whatever I can provide, it is nothing. Actually, it is meaningless. You have to practice all the things because as Monday is your exam, so only you have to just revise the things. Only quickly you need to revise those things. Okay, okay. So just quickly check the numericals and all the things. Okay, got it.
Yes, sir.
Hmm. Give me a second. So I'm just starting up my. Yeah. So, so the next is that can you go to the summary actually?
Yeah.
Just read out the summary. Okay, the energy, that potential energy we have done already. So now the next point, according to the law of conservation of energy, energy can only be transformed from one point to one place to another, one from to another. It can neither be created nor be destroyed. The total energy before and after the transformation always remains constant, right?
Yeah.
So that one conceptual numericals I have already given you. Okay. Okay.
Okay.
So make sure you do this. Okay. So total energy when an object is at height d or h, so the potential energy is mgh. Okay. Now it is coming down. It is getting converted into now kinetic energy, half of mv square. So this question is very important. Okay, just open that summary point I have shared with you earlier.
Huh.
Clear?
Okay.
Just open that. Can you
Huh.
share your screen?
Okay. Sir, can you stop sharing?
Yeah.
From where?
Uh, Go down. Go down. Yes, this is. So we have 3 points: total energy at point A, at point B, and at point C. Always equals to mg into distance or h. Okay.
Okay.
Now tell me. So tell me the steps so that where you did not understand.
So I'm saying, can you tell the whole chapter revision?
Huh?
Whole chapter's revision.
Huh? That is why I'm doing this as per the summary.
I didn't understand your question, sir.
So whole chapter revision you are asking, right?
No, no. Yeah.
Yeah, that is why I'm doing, right. So as per the, so we are going basis on summary that is given in the ncrt book, and also so one by one, so we are doing the main chapter, and we are main points, and we are describing, right.
Yeah.